We're going to start learning about triangles with the triangle inequality theorem, which focuses on the side lengths of triangles. The triangle inequality theorem says that the sum of any two sides of a triangle must be greater than the length of the third side. So if we look at this triangle, which has side lengths of x, y, and z, then if we know that this is a triangle, then that means that x plus y is greater than z. It also means that x plus z is greater than y. And it also means that y plus z is greater than x. So no matter what two sides you take of the triangle, when you add them together, they are going to be greater than the third side. Now let's look and see if these measures create triangles. First, we have 7, 5, and 4. Well, whenever we want to find out if these create a triangle, we're going to look at the two shortest sides. So in this case, I'm going to look at 5 and 4 because those are our two shortest sides. I'm going to add them together and say 4 plus 5. Well, if this is a circle, then that means that 4 plus 5 must be greater than the third side, which is 7. Well, if I add 4 plus 5, I get 9. So then I just ask myself, is it true that 9 is greater than 7? Since that is true, then yes, these side lengths create one unique triangle. So my explanation for this is yes, because 4 plus 5 is greater than 7. Next, we have 2, 1, and 5. So we would again take our two shortest sides, which in this case are 2 and 1, and we would add them together and see if they are greater than our third side, which is 5. So 2 plus 1 is 3, so then I ask myself, is 3 greater than 5? Well, that is not true. So that means that this does not make a triangle because when I add 2 plus 1, that is less than 5. You try this one. For this problem, my shortest sides are 6 and 3, so I would add 6 plus 3 together. And if they make a triangle, then they are going to be greater than the third side, which is 9. Well, when I add 6 plus 3, I get 9. Well, you have to ask yourself, is this statement true? Is 9 greater than 9? Well, the answer to that is no, because 9 is actually equal to 9. So it's important to note that when I have two small side lengths that add up to the exact same measure as the third side length, that also does not create a triangle. Those side lengths need to add up to a number that is larger than the third side length, not equal. Now try the last one. For this problem, I'm using 7 and 4 since those are my shortest side lengths. When I add 7 plus 4, I know that they should be greater than my third side length, which is 8. Well, 7 plus 4 is 11, and then 11 is greater than 8, which means that this does make a triangle. Now we can also take this to find other possible side lengths. If I use the measurements 6 and 8 inches, what is the smallest and largest possible length? What I'm really doing here is I am really finding a range of lengths that the third possible side could be. So to solve this, what I would do is subtract 8 minus 6, which is going to give me 2. And then I would add 8 plus 6, which would give me 14. Now you have to think about this. If I did 2 plus 6, that would give me 8, which would not be a triangle. And if I did 8 plus 6, that would give me 14, which again would not be a triangle, because in neither of those cases were those lengths greater than the third side. What this means is that I would actually end up with a third side that was larger than 2, but smaller than 14. So 2.1 could be a side length, because if I did 2.1 plus 6, that's greater than 8. 13 could be a side length, because if I did 6 plus 8, that is bigger than 13. So anything in between 2 and 14, but not equal to 2 and not equal to 14, could be a possible side length. So to show this, I would say 2 is less than x, which is less than 14. And that is how we say this. So you need to make sure you know how to say this. If you read it, this says 2 is less than x, which is less than 14. This means that the third side length could be any number between 2 and 14, but not equal to 2 or equal to 14. So I'm showing you this again. You would subtract, add, and then you would put the range. So let's look at another example. 2 and 6. If I subtract 6 minus 2, I get 4. If I add 2 plus 6, I get 8. So that means my third side length could be anything between 4 and 8. So to show that, I would say 4 is less than x, which is less than 8. Try the next one. For this problem, when I subtract 11 minus 9, I get 2. And when I add 9 plus 11, I get 20. This means that x could be anything between 2 and 20 without actually equaling 2 or equaling 20. So the range is 2 is less than x, which is less than 20. Now solve the last one. For this, I would subtract 18 minus 10, which would give me 8. And then I would add 10 plus 18, which would give me 28. That means the third side length could be anything between 8 and 28. So I would write it as 8 is less than x, which is less than 28. Now let's go to page 40. On page 40, we are looking at the triangle angle sum theorem. For this theorem, we are only focusing on the angles inside of a triangle. Well, the angles in a triangle will always add up to or have a sum of 180 degrees. So if we know that we have a triangle, then we also know that all of the angles will equal 180 degrees when we add them together. So let's look at these problems. If I know that a triangle has an angle measure of 60 degrees and another angle measure of 80 degrees, then if I need to find the third angle, I can add these together. So 60 plus 80 equals 140. And then I can subtract them from 180 since I know that all together they equal 180. So 180 minus 140 gives me 40. That means that the third angle measure is going to be 40 degrees. Now for 110 and 20, I would add 110 plus 20, which gives me 130. And then I would subtract that from 180. 180 minus 130 gives me 50, so the missing angle measure here is 50. Now solve the last one. If I have 74, 28, and one final angle measure, I would add 74 plus 28, which would give me 102. Then I would subtract 180 minus 102, which would give me 78. So the missing angle measure here would be 78 degrees. Now, if I want to know if angle measures will create triangles, then all I need to do is add them together to see if they equal 180. So if I have 55, 75, and 50, I would add 55 plus 75 plus 50. Well, when I add those together, I get 180, which means that yes, this creates a triangle. Try the next one. We know that this does not create a triangle because when we add 80, 90, and 80, we get 250. Now try the last one. We know that this does create a triangle because when I add 74, 62, and 44 together, I get a sum of 180. Now, what does all of this mean? If we have three side lengths or three angles, and we know that together they do not make a triangle, we consider that triangle to be non-existent because it literally does not exist. If we have three side lengths, so what we did at the beginning, if we have three side lengths and we know that they make a triangle, then we call this a unique triangle. And it is called a unique triangle because it can only create one specific triangle. There is no way to manipulate those three side lengths in any way except for one to make a specific triangle. However, if we have three angle measures, so what we just did with angle measures, and we know that those angle measures can add up to 180 degrees, then this is actually an ambiguous triangle because we could create more than one triangle out of that. So for example, if I have an equilateral triangle, I know that all of the angles in an equilateral triangle are also the same. So all of the angles would be 60 degrees. Well, if this was 3, then every side length would be 3. Well, I can expand that, and all of a sudden, all of my side lengths are 6, but my angle measures inside of my triangle remain 60 degrees. I could even make it smaller. If all of these side lengths were 1, all of my angle measures would still be 60. So whenever we have angle measures that make triangles, we call it ambiguous because I can create an infinite number of triangles, but I do know that this is a triangle because I know that the angles will create a triangle. I just don't know which unique triangle I am referring to. So if I have side lengths of 8, 7, and 16, I want to know if that would make a triangle. No, that would not make a triangle because 8 plus 7 is not greater than 16. Because of that, this is a non-existent triangle. If I have side lengths of 5, 4, and 7, I want to know if that would make a triangle. This would make a triangle because 5 plus 4 is greater than 7. So because I have side lengths that make a triangle, I know that will create exactly one triangle. So that is a unique triangle. I want you to do the next two. Side lengths of 6, 12, and 6 will not make a triangle, so they are non-existent. This is because if I add 6 and 6, I get 12. Well, it has to be greater than the third side length. And since the third side length is 12, that is not greater, that is equal. So this is a non-existent triangle. For 13, 4, and 8, I know that this one is also not a triangle, which means it's non-existent, because 4 plus 8 is 12, and that is not greater than the third side, which is 13. Now for angles, I know if I have angles of 33, 62, and 85, if I want to know if it's a triangle, I'm going to add those all together. Well, if I add all of those together, I am going to get 180 degrees, which means this is a triangle. It is specifically an ambiguous triangle because I don't know which specific triangle it's referring to, but it does create some sort of triangle. Now you do the last two. I know that angles of 28, 91, and 74 degrees do not add up to 180, so this is no, not a triangle, which means it is non-existent. For the last problem, I know that when I add those together, they do equal 180, which means yes, this is a triangle, and specifically, it is an ambiguous triangle.